Hi, hello, Diana. I'm sorry, you're not audible. Hmm. Yeah,
It would on my end.
oh yeah, I just can hear you. I just can hear you. Uh,
Awesome, awesome. It's
oh yeah,
great to be
good,
here.
good.
I have.
Okay, so yeah. Okay, so before you deliver the talk, I'm going to introduce you to the audience. Okay.
Thank you.
Okay. Hello, everyone. Today and welcome to session 4 for day 1 of PyCon Indonesia 2020. My name is Zaki, and I will be the moderator for this session. Everything counts. Python, IoT, connectivity, hashtag Tech for Good by Diana Rodriguez. Diana is a full stack developer and DevOps with more than 20 years experience and a strong background in backend and infrastructure. In this talk, we will see how the combination of different disciplines such as web development, IoT, and connectivity has had and will continue to have positive impact on people's lives. Okay, Diana, can you please share your screen now?
Sharing.
So here we go. Without further ado, the stage is yours, Diana. For the participant, you can keep those questions coming.
Thank you very much. I think this should be my cue, right? Right. Well, it's great to be here. It's a great opportunity to be here, and I'd like to take the chance to say hello and selamat sore. Saya Diana Rodriguez. Saya ingin berterima kasih atas kesempatan untuk berbagi ceramah ini dengan Anda. Saya sangat senang berada di sini. Saya sudah bertahun-tahun tidak berbicara bahasa, tapi saya memiliki kenangan terbaik dari negara Anda. Terutama makanannya yang enak. Saya harap saya dapat menginspirasi semua orang untuk mengembangkan dan menggunakan kekuatan super teknologi mereka untuk memajukan dunia. Sekarang saya akan kembali ke bahasa Inggris because I've forgotten most of what I learned, but again, it's great to be here. And will you see everything count? It's the title of my talk: Python, IoT, Connectivity, and Tech for Good. And everything counts. If you had a joke, I love Depeche Mode, so this was inspired in that song. Excuse me. Before I start, I wanted to introduce myself. Like I said, my name is Diana Rodriguez. I am a developer advocate, a Python developer advocate at Monitc. I'm also a Google Developer Expert, Azure Ambassador, and Microsoft MVP. And you can check my website is superdie.dev. I'm also on Twitter at Katufa82. That means popcorn. And you know what? When I was making this slide, I was so excited that I wrote my website not once, but twice. I just realized this. So, what's up? Tech for Good. Everything counts. And you're probably going to think that this is crazy, but I'm going to start with something completely out of the subject. I'm not going to start with Python. I'm going to start with diabetes. I know it's been a recurring subject for me, but look at this. I am a bionic woman. I have a sensor in my arm, and that's because I have diabetes. And it's crazy because I'm 37 years old. I'm too old to be diagnosed at this point, you know. Well, that's not true. I got diagnosed nearly 2 years ago, and it felt like I was being literally chopped in pieces. I felt like I was falling apart. And getting that diagnosed was one of the most difficult experiences I had. And this actually is the inspiration behind the work I've been doing for the past couple of years in the fields of development, IoT infrastructure, everything, tech for good, connectivity. I've been thinking of ways to help people who have gone through the same diagnosis as I have, and also those who have juvenile diabetes as well. But before we get into the technical details, let's talk about diabetes. There are many types of diabetes. Type 1 is an autoimmune disease where your body stops producing insulin, so you depend on insulin pens or pumps to counteract the levels of blood glucose and regulate your processes. Type 2 is when your body produces insulin but doesn't know what to do with it. And there are other types like 1.5, which is the same autoimmune disease in type 1, but it's diagnosed as an adult. There's type 3 for those who don't have a pancreas, and gestational diabetes for pregnant women, and many other types. But why the fuss? Why the whole scandal about it? Diabetes is a very common disease. It is expensive in the United States, which is where I am now. And back in 2016, the average out-of-pocket monthly diabetes cost was $360. That's 2016. That's for people who don't have access to insurance. I do have an insurance now, but you know what happens? If I lost my insurance, the cost I would have to pay for all supplies, insulin, and all my treatments, and even the sensors would get up to probably $2,000 to $2,500 per month. I know that's expensive, and the cost is different in every country. Every region has its differences and constraints in terms of access to medication, to technology, to things like sensors, etc., etc. So, yeah, we can't solve that problem with technology yet, but it's part of the problem, and it's part of the solution that we can propose. What happens, again, going back to diabetes, you have to run an automated process that the human body is running automatically. You have to run it manually and kind of see what happens. Imagine you're actually responsible of the Linux kernel on your own, and you have to be in front of that screen regulating everything that happens. You know, that's quite the task, and it's the same thing with the human body. So you're given a sliding scale, you're given some values, a range of values that you're supposed to maintain yourself within, and then you're given a medium, you're given insulin, you're given certain technology, you're given some information, and then you're told that when you eat food, it has carbs, it has protein, it has fats, and that you have to regulate your insulin based on how much you eat, and then you have to start counting carbs, and it's a complicated process. And I know it sounds discouraging, and it can be discouraging at first because we're truly never in control. If I give myself too much insulin, I can die. If I give myself very little insulin or not enough insulin, I can die. So again, this is something that technology can help with. I always share this picture, and I'm going to actually show you a picture of my 7-year-old niece. Every time I talk about using technology for good, of using tech for the betterment of the world, I have to show her picture. She proudly asked me to share this picture of her with her insulin pump and her sensor. And she wants you to know that she's very grateful for the worldwide community and for the efforts on making, all these things happen. But anyway, more context would be useful. Now, let's start to get to the technical side of things. There are plenty of technologies that have been developed in the medical field that are extremely useful, not only for diabetic patients in general. In our case, there are sensors like these ones and insulin pumps in the market, and they solve two big problems. The first one, well, sensors like these actually save me the time of having to prick my finger every day, 8 or more times a day. I probably still have to prick my finger to make sure that whatever is automated here is not too far from where it should be. But that would be probably once a day or once every couple of days versus 8 or more times per day. So sensors solve that problem, and that's amazing. And we can get blood sugar readings. I can actually get and show you live that my blood sugar right now is 157. Sorry. And that I am okay. And I can have access to that information in my watch as well. So that's one problem that is solved. The other problem is, well, with insulin pens, there's an inconvenience. They're very practical. I can just select how many units I want to give myself and just inject myself in the abdomen or in the arms or anywhere I find suitable. But after a while, it gets old. It gets tiring. You don't want to stick a needle, many times a day. It just gets tedious. So insulin pumps solve that problem by attaching to your body and delivering insulin continuously with some settings for up to 3 or 4 days. So yeah, technology works and that's great. But there is a problem. We're never fully in control up to now, until now, because insulin pumps and sensors don't speak the same language and they don't communicate. But anyway, that's something we can talk about. The first problem that was solved with this technology, having access to the data from these sensors and from those insulin pumps to help communicate that information in a more efficient way for monitoring was through online monitoring. There's already an open source solution, and it's called Nightscout. Nightscout is basically a web-based continuous glucose monitoring system that shows real data, and it can do a prediction up to 30 minutes using a second order autoregressive model. There's a server that is reading from a MongoDB, and that database is basically storing the data from this sensor. There are alarms that are generated for high and low values, and it's free, open source. And that's grand. That solves a cool problem. So I have my sensor. The data goes to my phone because it's connected through Bluetooth Low Energy. That data goes to that dashboard, that open source dashboard. And then also with that data, I can also send the insulin pump data, and then I can make better decisions for bolusing. But yo, look at this. Lihat di sini. If you want to check my dashboard live, you can go to this address. It's dynamics.superdi.dev. And that is a faulty pancreas club dashboard where you can see my blood sugar levels in real time. You will see, let's see, 157, and it should look like something like this. I actually took that screenshot because I like the way it looks. That's actually a really good number for me. And it's not common for me to be in those awesome numbers. So I took a screenshot and decided to brag about it. Every time I talk about diabetes, I show this picture. So anyway, we've got the data, and that's cool. Someone else took care of putting these solutions together. But now what happens? The next step is automation. Now that we can obtain those details and that data for monitoring, the second way to contribute is through automation. That is already sold, basically, through OpenAPS. And this is a DIY, do-it-yourself implementation. It's called OpenAPS because it stands for Open Artificial Pancreas System. Anyone who can have access to these boards, who can purchase them, and they're not extremely expensive, they're not cheap either. It's not like they're extremely cheap, but they're not super expensive. Thinking about the cost of a more complex system, the price is source of fair, but we're working on reducing that in the IoT community, especially in the IoT oriented towards diabetes. This open source artificial pancreas system is a safe, powerful, and advanced, but easily understandable artificial pancreas system, and it is designed to automatically adjust the insulin delivery of an insulin pump to maintain blood glucose in a safe range at all times. So it basically mimics what a real pancreas does. So what it does is it communicates with an insulin pump to get all the details of all the recent insulin doses, communicating with a continuous glucose monitor, like the dashboard I showed you, to get current and recent blood glucose estimates and issuing commands to that pump. So it basically adjusts the insulin dose as needed. So these are DIY implementations. The most common are the Riley link. On one side, we see the 433 megahertz to BLE, that's for the Omnipod, and then the 916 megahertz to BLE for Medtronic pumps. Those are the two most common pump types out there that can be used to do what we call looping, which is basically automate the process of monitoring and administering insulin and letting the algorithm magic work its way. It has been amazing. There are there's a huge number of people who use different DIY implementations until today, and the cool thing is that it's heavy on Python. The third thing we can solve with this technology in terms of monitoring, it's the hardware. So this is where I start grinning, because these implementations have interesting possibilities with Python and IoT, namely CircuitPython and MicroPython. So there's a fact worldwide. I'm going to describe the three pictures you see on screen. The first one is the most expensive implementation of them all, which is the one I have because my insurance covers it. It's the Dexcom G6. These sensors cost around $350 per month out of pocket. And then you have to buy a transmitter that costs around $400. So it would be like $700 per month. The second one you see on the right side is Medtronic and Guardian. And this is a pharmaceutical company, a company that basically developed a system to communicate, to establish communication with a sensor to a pump, and that way trying to automate the process in a more official and approved way. But guess what? It is also extremely expensive, and it's not as accessible in countries in Latin America or in Southeast Asia or everywhere else. Even in Europe, the access is quite limited because it's very expensive. The third one, and that's the base of my current work, is the Abbott Lever Freestyle. And this is a tiny sensor that you can just place on the back of your arm or on the sides, and then you have to use your phone or a scanner that they also sell that has a glucometer integrated to it. And you basically have an RFID tag that you scan, and then you can see on your phone what your sugar levels are. Now, yeah, fact is, when it comes to open source, things have to be free or the most accessible possible. We want to make this accessible to everybody, right? The problem with the last solution I showed you is that it doesn't transmit automatically like the other solutions that are very expensive. So you have to build your own IoT implementation to transform this RFID tag into a continuous blood glucose monitor. But good news, there are ways to make that happen. So what's our contribution? And I say our contribution because this is something we can all do together, not just me. We can all participate in this. We can improve the open source solutions to guarantee access to hardware that is more accessible, that is cheaper, that allows us to transform this this sensor into a sensor that transmits data automatically. There are commercial solutions like the Meow Meow 2, and it can be purchased in China, but it costs within $159. It's say between $120 to $160, and you can only buy it from this particular company that is in China. They're really big, they're amazing. But if we think about accessibility, not everybody has the chance to buy the sensors and then that little thing on top for that much money. So my desk kind of looked like this because I was trying to test the open source solutions that are already available. And there are ways to make this work without these many trinkets. And I invite you, this is the first invitation I extend to all of you. I have a fork of the limiter, which is something that the diabetes community developed as a community, an open source solution that turns the Freestyle Libre into a full CGM. Obviously, there are advantages to building something on your own. There are advantages to using MicroPython or CircuitPython to basically help with this task. And I invite you that if you want to help me make this possible, not only in terms of code, but also for those who are into 3D printing, for those who are into for designing and trying to find a smaller and more comfortable and efficient way to make this happen, to please contact me and let's work together to make this a solution that is accessible to everyone. There's no commercial gain in this. The idea is to make this hardware efficient, small, comfortable, and on top of everything, accessible. In any case, all the instructions are there, but then it gets even more exciting. My personal project includes developing a way to send this data using a WISP-block, which is this device we see in here. It's a modular IoT system from Rack Wireless, and it allows to build solutions and to build on top sensors like Lego blocks. So it's a modular plug and play system, and compared to other systems, it has several advantages. And the first one of them all is size and portability. So it uses a compact connector, making its size very small. And this base plate is 30 millimeters by 60 millimeters in size. And this base can contain a microcontroller, an I/O module, and up to 4 sensor modules, all at the same time. So the use of an industrial grade connector allows you to use the same modules from rapid prototyping to testing final production projects. And it's not only modular on a hardware basis, but it has ready to use software blocks. It's simple to create an application to meet any implementation requirements, and it does officially support CircuitPython. I was in the Adafruit meetup where they announced this support, and it was the happiest day of my life because it means that implementing this project will be so much easier. The final idea of this WISP block is to expand connectivity and portability beyond the internet and dependence on a cell phone or a mobile phone. Like it happens now. I can send this data to the dashboard I mentioned to you because I need to use not only this data, I need to be connected to the internet. But if I don't have internet, if I'm out of range, then none of this data gets anywhere. You don't see anything in that dashboard that I showed you. So the solution basically is about using CircuitPython as an approachable programming language for IoT for and from the Python community to make this much approachable, much easier, and give the chance to developers to get acquainted with IoT solutions using a language that we're familiar with as a community. Then on top of that, we're expanding connectivity with Helium and LoRaWAN. We integrate that into data transmission. With this, we can not only transmit glucose data, we can generate alarms. And in case of an emergency, we'll be able to share the exact location of those who are in crisis. If any of you want to contribute on the IoT side with CircuitPython and are interested in expanding connectivity with LoRaWAN, contact me. In addition to all this, Helium offers an incentive to expand connectivity, giving those who implement hotspots, Helium hotspots, the possibility to mine cryptocurrency. So nowadays, LoRaWAN is not only available for commercial solutions, for industrial solutions. We're trying to make this available to the people as a people-powered network, and we want to put this to use with all the superpowers from our development side, from the Python side, with an application I'm going to show you very soon, and from the IoT side, using a language that we're familiar with an IoT side, CircuitPython, MicroPython. Unfortunately, the demo gods were not in my favor today, and that's why I cannot show you a full demo where I get the data with this implementation. But to illustrate the idea, here we see the advantage of expanding connectivity and adding possibilities to offer real-time location, sending GPS data, establishing a very specific condition of, if whether the glucose values are above or below the established, it will not only send an alert that there's an emergency, but we're able to share the specific location of, this person. With LoRaWAN, we're eliminating the dependence on cellular connections, and we're expanding the possibilities of obtaining an approximate location of a person in times of crisis. Although the number of hotspots, it's not large at the moment, we have the possibility to open this universe to our local reality and to expand a secure and reliable network that opens the doors of connectivity to another level. It is no longer a tool used by companies in remote areas anymore. We can bring these benefits to ourselves for the benefit of a community, for the benefit of our own community, of our people, of ourselves. So if I explain this, what we see in the slide, it's basically the sensor for blood glucose, the Libre sensor, with a do-it-yourself IoT implementation called Limiter that we're constantly improving, that tags that RFID, it taps it, it scans it every 5 minutes, and then sends that data over Bluetooth Low Energy to this WIS block. This WIS block is basically sending that data through LoRaWAN to a dashboard. And then we have the possibility of also sharing GPS location without having to depend on a mobile phone. Obviously, this is much smaller. I have it mounted in this clear base because I'm prototyping at the moment, and I'm carrying out some testing. But offering that option of having possibility and not depending entirely on a mobile phone connection is already a huge gain. But wait, there's more. This is the Python side, and I've shared it a couple of times before. We have a solution that is ready to be deployed, that is out there, and that is written in a friendly framework for anyone who wants to contribute. My favorite part of the day is to say Flask in action. This is an application made in Flask using materialized CSS, Jinja templates, and the Monitc communication APIs. These are the links of the application. I disabled some of those functionalities just for demo purposes, but you can actually test it, as in you can get acquainted with what it does, and you can fork the repository. And on top of that, if you want to contribute with more features, you can do so. And you might be thinking, so why Flask? I needed something quick. I needed something that I could share and allow others to contribute on top. Flask was my choice, and it has always been my choice because of its friendly features, because of the freedom to build whatever I want without any constraints. It is a minimalistic framework, and it has a very low learning curve. And I needed something that was friendly and and easy to work with, regardless of your coding experience. So what happens? What does this application do? Do you remember how I showed you my mobile phone? And there's an app that is constantly getting this data from my blood glucose sensor. Well, it has those apps have alarms, but I never hear them, especially when I am sleeping. So this is when we can make the best use of the Vonage APIs. But how do we do this? Okay, so we have a range of values for low and high blood sugars, and we have a mobile phone. What happens? I can always hear my phone ringing. So what we can do is use the SMS and voice APIs to notify my emergency contacts if there's any irregular situation. We need to capture at least the last 60 minutes of readings from that dashboard I showed you before. the Nightscout open source dashboard. We're going to use that data, and we're going to use a thread, a Python thread, with a scheduler. If those values are above or below what we establish as such, as high and low, through environment variables, then it fires an alert. And then if the dashboard is offline, it will fire an alert. What kind of alert? Well, I will get a phone call. Diana will get a phone call after a certain time at night, because during the day, well, I appreciate the call, but I don't receive it. I can establish that condition. The solution is simple. This is the login panel. I use Firebase to control the signing through Google with your email, and then you can configure the endpoint where you receive the data from the Nightscout entries, my phone number to receive a call if my levels are abnormal, an emergency contact, in this case, my mom, in case I don't pick up the phone, and up to 5 emergency contacts that will receive a call one by one. And if the dashboard is offline, they will also receive a text message. If no one picks up, they will also receive a text message. The idea is to offer a good alarm system, a good network of emergency contacts. And if anything happens to me, I know that if I was unconscious at some point, someone would know that I'm in trouble. But you can see all the details and the step-by-step tutorial at this link, nexmo.dev/Nightscout. It even covers deploying it to different solutions. If you go to the repository, you even see a deploy to Heroku button. And this is where I invite you to take on the Tech for Good challenge. Are you up for the challenge? Contribute, if you'd like to this repository. You can suggest features. The app is very well documented. You have unlimited access to the tutorial. If you need codes, I will be providing codes for anyone who wants to try the Monitc APIs, and also for anyone who wants to contribute with this challenge. We need everything from translations, from perhaps improving the documentation, suggesting new features, design, anything and everything counts. I think that we often ignore the fact that we can make such a huge difference with all the technology and all the knowledge we know. We have superpowers that can have a positive impact. Anyone can contribute. Any of you, any of us can make the world a better place using technology to improve quality of life. We can use our superpowers, and I hope that my words can inspire you to contribute not only with diabetes-related projects. There are plenty of fields where you can make a huge impact just by contributing. This is what open source is about. We all have the chance to make a positive impact in the world. I hope you can count on me for anything I can help with on the Monitc side, on the Python side, on the MicroPython and CircuitPython side. I might not know all the answers, but I assure you that we can find them together. It was definitely a privilege to speak to you today. Thank you very much. These are my details. Please feel free to contact me. Don't be shy. Let's work on something together. Here's the link to the slides, and you can have access to all the references and the resources I mentioned. Thank you very much. Terima kasih.
All right, thank you so much, Diana. Terima kasih. Oh, by the way, I'm Budi. I have to replace the other moderator because he has like some kind of internet connection issue. So yeah, I'm
Thank you,
Budi,
Budi.
and wow, quite surprised you can pronounce in Indonesian language very, very fluently. It's amazing.
Thank you. I
uh,
lived in Indonesia 6 months, and it was
all
the
right,
best 6 months of my life.
all right. That's pretty impressive. Oh, by the way, are you ready for the Q&A sessions?
I
Because
am.
we have some questions from the audience. Let's see. Questions number one. Do you have any difficulties when you are developing this system? What most difficult implementation when you are build this?
The most difficult part was on the IoT side because I had to learn a little bit more of Arduino, and I had
Mhm.
to wait until the Circuit Python implementation was ready.
All right.
But once you're a programmer, if you can read code, it's kind of like, well, you can figure out your way around things. On the Python side for the app, it wasn't as difficult, but I
Mhm.
do have particular issues with
Okay.
design. So on the website, I know I fell a bit behind because the UX side is not my forte.
All right. All right. All right. And we have second question here. What measurement that can be covered with that sensor? Do you inject the sensor to the body or like
Yes,
how the sensor works?
yeah, it is.
All right.
It is
Okay.
actually injected in my body.
Mm-hmm.
The measurements are only blood sugar levels, and it's
Okay.
approximate.
Mm-hmm.
There's an error margin of up to 30%,
All right. All
but
right.
it gives you a good estimate. Blood sugar.
Mhm.
There are other sensors in the market that can do blood pressure and that can measure other things like saturation. But yeah, there's a tiny, not a needle, but more like a fiber under my
Mm.
skin
All
that
right.
is not taking it from the blood, but from interstitial fluid.
Mm. Okay. All
So
right.
it works well.
So basically, it will automatically inject an insulin when the insulin level is below the threshold, or
With the pump, yeah, because this one is
yeah.
only for measuring.
Okay. All
Then
right.
I've got a pump. It's in my bag, so I can't show it.
Okay. All right. All right.
But what we do with this implementation is to automate that process of
Mm.
injecting insulin
Okay.
when levels are high. So that's
All
why
right.
we need this communication that we
Okay.
implemented. Yeah.
Okay. That's pretty cool. And we have third question here. How frequent is sensor required to be recalibrated?
Not that often. I
All right.
think
Okay.
in 10 days, I think I've calibrated
Mm.
twice.
Okay. All right. That's not too bad, right?
No,
It's
not too
pretty good.
bad.
Okay. And we have another question here. How long do you get the data from getting the accurate result and how you get the data?
So the data starts broadcasting automatically, and
Okay.
then it's stored in that database.
Okay. All
So
right.
obviously the algorithms already work their magic powers, and they show you what the predictions are going to be. And the longer you keep using them, the more accurate those predictions are going to be. But yeah, it's automatically as soon as you're connected.
All right. That's pretty cool. Okay. This is a very interesting talks for me. It's really awesome because like it show the power of technology to save lives. So super awesome. Thank you so much for being with
Oh,
us
thank you.
and yeah, thank you so much for like this is about 3 or 4 a.m. right in your time and oh my
Yeah.
gosh, you are so awesome.
Oh, thank
Thank
you.
you.
I love Indonesia. I love my heart is in Southeast Asia. So thank you.
All right,
Terima
all right.
kasih.
Terima kasih. Thank you so much. Okay, I have to close this session. Thank you. Bye
Bye
bye.
bye.
Bye bye.